Welcome to week 6, day 25 of the fall 2024 Programming Fundamentals with C#. This is Jim Kaufman with Rankin Technical College. So today we have a list of items to cover, and this will be primarily about Chapter 12 is how to create and use classes. As far as the assignments this week, well, no hands-on tests this week, so we can take a break from that. There will be a written test and 2 lab assignments. And even though there's not a hands-on test, please don't wait until the last minute to start working on these labs and the written test, just because this is a little more challenging when we start talking about classes and objects. So really try to spend a little bit of time every day working on this. I hate for you to start working on it on the weekend and run into problems. So, please try to work on it throughout the week. So first, we're going to go ahead and go through chapter 12 here a little bit. Okay. So what I kind of do here, I'm kind of doing a split screen. Actually, it's this book, and it's on the right hand side because it refers to certain things in the book, and so I'm trying to be able to so we can kind of look at some of the things while we're reading the text, going over the text. We can also see some of the figures diagrams that are associated with that. So just to start out classes, as far as classes, classes are something you can create on your own, and they should be self-contained entities, so to speak. So we've been, using WinForms apps and console apps as well. But, WinForms apps are very, they're wired together. There's, a lot of special configuration for WinForm apps. Now, when we create all of these objects we're going to create, they should be self-contained, whereas they're not really dependent on the WinForms apps for the most part, and actually could be used outside of the WinForms apps, okay? So we'll look at that a little more. So as far as classes are very, used typically within a business application. You might have a product class, a order, a bank for a bank account, so forth. So you can have, multiple different classes for different business concepts, for different business areas. Okay. And within that class, you're going to have a variety of different members that you can add to a class. Okay. Now, what's very typical in business application is using a multi-layered architecture. And that's where you kind of break up your code, your program, your whole project, I should say, into multiple layers. So you can have like a presentation layer, a middle layer, and a database layer. So your presentation layer for like WinForms apps, is obviously that form is your presentation layer. And then you can have what's called like a middle layer. And that's where you have your business classes. You do like a lot of your business logic. And then you have what's called a database layer. And that's where you have database classes. And basically what those database classes are doing is they're actually, sending data to the database or retrieving database back. They pass that back to that middle layer. The middle layer does some business validations on that and returns it back to the presentation layer, okay? And it can also work in the other way. Is you have something on your presentation layer, maybe you have some fields, you enter some data, that would go to your middle layer. You do some business validations and some business logic on that data that you entered, and then that would call your database classes on your database layer, and that would persist that data to the database. So when we talk about saving data, there's different ways to save data. In this case, it shows a database. You can also, save data to your computer itself. The idea of saving data is actually the concept of persisting data. So you can say you persist data to the database, or you may be persisting data to your file system. But the concept of having data that once your application stops or closes, you still have that data when you come back again, okay? When you fire up that application again. So that's all about persisting data, right? Now this is, as far as this multi-layered thing, there can be multiple layers, and sometimes, not every layer is always there, right? And we're not going to be, it'll be a while until we, really get into having that all set up right, okay? Um, yeah, and so like I mentioned, although we refer to this layer for the database layer, it can also contain classes that work with data that's stored in a file, okay? And then the middle layer includes classes that correspond to business entities, for example, products and customers. May also include classes that implement business rules, such as discount or credit policies. When the classes represent business objects, they are often called business classes. One advantage of developing an application with a layered architecture is that it it allows application development to spread among members of a development team. For example, one group of developers might work on the database layer, another group on the middle layer, and then another group on the presentation layer, right? So I don't know if you've ever looked at jobs or ever heard of the concept full stack developer. So when you're talking like a full stack developer, that means, companies do things differently. And but full stack developer would be that you work on all three layers. You can work on the presentation layer, the middle layer, and the database layer. That's really called a full stack developer. Now, a lot of that, it depends on the company. Things are different. Between companies, even teams even teams within a company, and even within projects itself, they can run things differently. In some businesses and some companies, they have designated people that work just on the presentation layer or the middle layer or the database layer. Whereas other companies, they want all their developers to be able to work on any layer, so they can give them an assignment on any layer and they can do it. Or if they need to build something new, they can, they'll have the skills to be able to do the whole thing, right? Now, there's some, advantages and disadvantages. Some of the advantages was basically like I just said, is you can have one developer who can work on different layers, which it's a very nice advantage there. But usually, you know, some of very specialized companies that work on some very, how should I say it, very high quality type applications. They tend to break things up into different layers and have, they have developers that specialize in those layers, right? So the advantage of that is, if you specialize in an area, you're going to know a lot more about that area, right? So they're almost like experts in each area, right? And so, that can actually build a much more of a quality type application, right? Not to say you can't still build a quality application knowing multiple layers, but there's some advantages to doing that. And it all depends on the company you work for, and like I said, it could be different on different teams and different projects as well. So I just wanted to point that out. So here, Okay, the classes in the database layer, all the application data processing. I think we kind of covered that. Business layer, domain layer. Yeah, also that's another thing. A middle layer can be called business layer or a domain layer. It's synonymous with that. When a class in the middle layer represents business entity, the classes can be referred to as business classes. Yep. Business objects. Yep. Often the classes that make up the database layer and the middle layer are implemented in class libraries and can be shared among applications. Yep. Yeah, so we're going to talk just a little bit about class libraries here in a little bit as well. And also another thing about this, I kind of want to mention as far as like when we're talking about presentation layer, we're in this course, we're doing the WinForms apps or the console apps. But, presentation layer can be other things, right? It could be a mobile device. It could be a web application, right? A browser, right? That's your presentation layer. It's basically HTML that's running within the browser, right? So there's other presentation layers as well, okay? And another good thing about the three-layered application is that when you divide things up, sometimes, people, especially, newer developers and less experienced one, it gets easy, and that's how we kind of start a lot of the assignments. We kind of have everything, in the forms, right? Everything's got in that presentation layer, so to speak, right? But it makes a lot of sense. So maybe you develop something at your company, and that might be able to be used by a WinForms app or a web app or a mobile app. So you want to be able to make that available to multiple different presentation layers, right? So by having that layered application, if the middle layer, like your business classes, are self-contained, then it can be used by different presentation layers. Or if you decide to change your presentation layer, you can change your presentation layer and still have your business classes intact, right? Let's see, the third advantage is saying here, different servers. Yeah, so sometimes, while we're running everything locally here, but, when you actually in a customer environment, you're going to be running things on servers, right? And they're, usually they're probably not in-house. Sometimes sometimes they're in-house. Some places have some in-house, and nowadays there's the cloud as well. So, but it could be at a data center, it could be in a cloud environment. And so you could have your presentation layer on one server, a middle layer on a different server, and database layer on another server. So there's some advantages in doing that. It's from a performance and from a security standpoint that you don't have everything together, right? So from a security standpoint, if somebody is able to hack into your middle layer, hopefully they can, they're not able to get into your database layer, right? So by compartmentalizing that and having that separate, it provides more security, right? And then also certain things need more, a database needs a lot of resources, so you can build your servers based on what resources you need for a specific layer, okay? So, okay, here we different members of a class. Of course, not every class you create will contain all types of members. So the classes you design yourself can have properties, methods of constructors, and events. We're going to go through all of those. Let's see what's here. I don't think we're at that point yet. So I did want to bring up a concept. It's called encapsulation. So it's one of the things of object-oriented programming, right? So when we build class, when you're using, C sharp is an object-oriented language. It has all of the, you have to follow certain things. You have to be able to do certain things in a language for it to be considered an object-oriented programming language, and encapsulation is one of them. And encapsulation is about basically being able to hide or encapsulate some of the data or operations of a class while exposing others. And so what you kind of do is you set your fields, so it's like instance variable fields, you set them private so that nobody outside of that class can access those private variables. They only can be accessed within. And so that's one of the main concepts of object-oriented programming is encapsulation. So you do that by making them private, right? Use the access control, and then you allow access to them in certain ways. And we can use public properties to access those fields, okay? So that people outside, but they have to use those properties. They can't directly change the values of those variables, okay? And we're gonna take a look at that here. So here, let me just make this big, I think. All right, this is not cooperating like I wanted to. There we go. All right. So I'm going to show you here that there's a product class, and the product class has different properties. It has a code, a description, and a price. Now, when we talk about properties, okay, properties are going to start with an uppercase letter. Okay, so you've got uppercase C for code, uppercase D for description, uppercase P for price. The code is a string that contains a code that uniquely identifies each product. We have a description is a string that contains a description of the product. And we have a decimal that contains the product's price. Okay. And then we have what's called a constructor. And a constructor is actually used to create an instance of an object, an instance of a class. If you recall, a while back ago we had and I know it was in the written test and covered a little bit, but class is basically a blueprint, and you use a class to create objects, right? And creating an object is called instantiating an object, right? So when you call what a programmer does, it actually calls the constructor to create an instance of the object. And we'll take a look at that here in a minute. So we're going to talk about the types of different class members, the property, right? And we already talked about properties up here. So we have property represents a data value associated with an object instance. We have the method, an operation that can be performed on an object. And we have a constructor is a special type of method that's executed when the object is instantiated. Now let's not really, I don't want to worry about delegate or event right now. Field is a variable that's declared at the class level. We've done that. We've done a constant before. Okay. And yep. So a class and object concepts. An object is a self-contained unit that has properties, methods, and other members. A class contains the code that defines the members of the object. Okay? An object is an instance of a class. In the process of creating an object, it's called instantiation, right? Encapsulation is one of the fundamental concepts of object-oriented programming. And that is what allows you to control the data and operations within your class and what is exposed to other classes. The data of a class is typically encapsulated within a class using data hiding. And we'll just talk about that a little bit more here in a bit. I don't want to go too deep yet. Although a class can have many different types of members, most of the classes we'll create will just have properties, methods, and constructors. So here we're going to look at a product class. And let's just go through that. So here you go. We have a class called product. It has 3 fields: code, description, and price. You notice all 3 of these are private, right? And so basically, when we say encapsulation, that's what we're doing here. This is actually called data hiding. We are hiding code and description and price. We are hiding these fields from anybody outside this class, from any other class outside this class. You can access these. You can get or set data, but you have to follow the rules to do that. Okay? And then you basically use what's this property, do a get or a set, right? And so the get will return the code, and the set will set the code and basically whatever value you assign to that. Okay? And there's one of these for code, description, and price. But like I said, you got these 3 fields: code, description, price. They're private. Here is called an empty constructor. So you can you use the new keyword to create a new product. So there's different ways to create a new object, and you can create it by calling this constructor, or you can pass in your values calling this constructor. This is a secondary constructor. This is a custom constructor. Okay, and you basically, when you create your new object, you just pass in the values right when you create them. When you do it this first way with the empty constructor, then you've got to assign a variable. Let's just say call it product1 to product. And then you've got to do a set code. You have to do separate lines for setting the code, setting the description, setting the price. Okay. This is a little more, easier, concise, I guess, to say. And you don't necessarily always have to. In some cases, you might have variables assigned up here that you don't even want anybody to access them anyway. And when they create a new product, they might just do a code and a description, and the price gets added later, and you don't even have price here, right? And, I'll show you about that. But the important things to remember, is you're going to have fields. You're going to have an empty constructor, a custom constructor, code properties, and, different properties for each of your variables: code, description, price. Okay. Now, the process of creating an object from a class called instantiation, we say that over and over again. Here, you can see there's 2 instances of a product class. Each instance represents a different product object. I think I could just show that to you right here. So here's 2 product objects that have been instantiated from the product class. You got product 1 and product 2. And it's showing here. Let's just actually make this a little bigger. So this is creating two products, product 1 and product 2. And then here, like I said, that we had that constructor where we had all those fields right there. So you can just actually put you have to make sure you're in the right order. The first one was the code, the second one is the description, and the third one was the price. And so then you can create a object like that. That's one way to do it. Here, you code that creates an object and initialize it manually. So you create a new product here, and then you're setting product, while you create the product object and assign it to this product 1 variable. Then you can do a code, a description, and a price to set those values, right? And this is what's called an object initializer. And so basically here you kind of do the same thing, but you just you can actually just refer to code, description, and price, just like that. So here also there's 3 ways to declare and create an object in a single statement. So here is just what we were kind of seeing above here. This is basically you're explicitly typing in product 3 equals new product, right? But there's other ways to do this as well. This is the more traditional approach, and in recent times the language has evolved. So what it's doing here, this var basically means since you're instantiating a new product, the compiler says, oh, I understand that you're instantiating a new product, so you don't have to state that it's a product. I know it's a product because this is what you're trying to do here. So that's why you can do it this is how you can do it like that without having product there. Okay? And then here is another way. And basically here, you're basically saying, I got a variable product 5 of type product. So the compiler says, oh, I know that you're wanting to instantiate a product, so you don't have to put that all here. You can just say new. Okay? So basically that's what's happening. It's the compiler's realizing, oh, okay, I know what you're trying to do here, so you don't have to necessarily give me this whole explicit typed statement, okay? So when an object is instantiated, a constructor is executed to initialize the data that makes up the object. If a class doesn't provide a constructor, so when we seen that first constructor, here, even if you don't include this, you can actually not have any of this here at all, right? But by default, since this is a class, by default, it's going to create the object using this, even if it's not stated here, okay? You don't even have to state it. But it's just kind of common practice to state it. The data that makes up an object is sometimes referred to as the object state. So basically, when you're setting all these variables, and once you have those variables set, that's the state. So let's say you have object 1, and you set a set of variables on that object. That is the state of that object. Now let's say you created another object called object 2, and you use different data to create that one. So the state of object 2, this is different than the state of object 1, right? The state of an object, The state of an object changes whenever you change the value of one of the object's properties or public fields. The state can also change when you call a method that affects the data stored within the object, right? So when you create an object in the first place, then you have that state that's in one state, but then you could take that same object and change the state on that object. You run that. You can do a set on that method, that's a set on that data that would change that data, right? So the state would change in that case. An application can create two or more instances of the same class. So like we said, object one, object two. In this case, it was product 1, 2, 3, I think all the way up to product 5, right? So an application could two or more instances of the same class. Each instance is a separate entity with its own value, with its own state, right? And we'll talk, another concept I just want to bring up and we'll talk about a little bit more is even if you use the same values, let's say you used a set of values to create one object, and then you create another object with the same values. Those two objects are not equal to each other because they are the way objects work. The way objects work is they're stored in memory, and they're in each object. When you instantiate an object, it's stored in a different place in memory. So those objects will never be, even if they've got the same data, they will not be equal to each other. Okay, and we'll go through that more in the future. But comparing that to, let's just say you had a variable called, let's say you had an integer x equals 10, and then you had an integer y equals 10. And if you said, is x equal y, it would be true, right? Because 10 equals 10. But in objects, it's different because of how it's stored in memory. Okay, and that object is a unique object. Every time you instantiate an object, even if it has the same values, it's unique. Okay. A class defines a reference type. That means the variable that's used to access an object instance from a class contains the address of the object, not the actual object. Yeah. So actually the reference type, when you assign a variable, when a class defines a reference type, when that variable that's assigned to that is actually a location in memory. Okay, it actually points to a location in memory. So like I said, every time you create a new object, it's going to point to a different location in memory. Okay. So we'll go ahead and create an object. Yeah. Okay. Yeah, we're going to create an object and we'll create a class within the Visual Studio here in a little bit. Do want to talk about fields here a little bit. Okay, so a class can contain two different types of fields: instance variables and static variables. How to work with instance variables, you learn. Okay. So instance variables are associated with an object itself. Static variables are associated with the class. I know that can be a little bit confusing, but I was showing you how when you create an object, and if you have those private variables, those instance variables, you can't access them until you access them from an object once an object's created, right? Static variables, you don't have to have an object. You don't have to have the object created, right? And like we talked about the blueprint, the class is the blueprint. So basically from that blueprint, from that class, you can access static variables, okay? Instance variables are associated with the objects itself, okay? Shows you how to work with instance variables. I think that's just the next slide here. Let me look at his. Hold on, I'm sorry. Okay, a variable that's defined at the class level within a class is called a field, right? So we know that these are fields. Now, a field can be a primitive type. In this case, you got an int, a decimal. This other one's an int. So these are all primitives here. But it could also be a class, right? So maybe a product. A product could have other objects as well that you bring in, right? So actually, you can actually have a field could be a class itself, right? And this class could be a .NET class or structure. There's some built-in .NET classes, or a user-defined class or structure. You can use a private access modifier to prevent other classes from accessing a field. We already kind of talked about that. Then the field can be accessed only from within the class. An instance variable is a field that's defined in a class and is allocated when an object is instantiated. Each object instance has its separate copy of each instant variable. Okay? So when you create a new object, you set your data on those different instance variables, right? When you create another object and create they're not sharing the same data, right? Now, for us, I know we were actually defining things at the top of a class so that, different methods could actually share that data, right? But we weren't, we're using the the win forms is kind of all wired together and stuff. It's kind of a little different scenario there. But when, we create individual custom objects, right? When we create those individual objects, each object's going to have its own set of variables, and they're going to be distinct from the other object, okay? If you initialize an instance variable when you declare it, the initialization will occur before the constructor for the class is executed. As a result, the constructor may assign a new value to the variable. You can create a read-only field by specifying the read-only keywords in the field's declaration. Then the field's value can be retrieved, but it can't be changed. You can set the value for a read-only field when you declare it or in the code for a constructor. So basically what this is kind of saying, so you remember like when we did a const, right? A constant. So when you define a constant, you've got to declare the variable. Declaring is just stating, basically stating what it is, right? And initializing, it's actually giving it a value. And we do that with a const on the same line, okay? For a read-only field, you can state that it's read-only, but you can declare a read-only field, okay, and then initialize it when the program runs. It can initialize that variable, but once it's been initialized to a value, it can't be changed after that, right? So it's just a little bit different how read only and like a constant is. And a constant would be, there's compile time and there's run time. So a constant would be compile time. If you don't assign a value to a constant field that you stated as a constant, the compiler's gonna, and what it does within the IDE, right? Within your editor, your IDE, you're gonna see a little red line under that constant because you didn't give it a value, right? So that's whenever you see those red lines, that's always compile. That's telling you, it's kind of a feature within the IDE saying, hey, this ain't going to compile, right? It's not really compiling that when it does that, right? It compiles it, later on. But it's just, within the IDE, it's a special feature within IDE saying, hey, this ain't going to compile, right? This ain't going to compile. But with a read-only field, you can just declare it without assigning a value. And then when it runs, at run times, it assigns that value, not at compile time. Right? So at runtime, it will set that variable, and you can set that variable one time, but then you cannot change it after that. Okay, a public field is a field that's declared with a public access modifier. Public fields can be accessed by other classes within the application, much like properties. However, properties can have additional features that make them more useful than public fields. So basically what this saying is, we were looking at the private fields, and then you would use those property fields to get them or set them, or you could set it. But within that property fields, you can have other code in there that does other things, right? Now, if you make a public field at the top of your thing, you can just refer to the name of that variable and assign that to anything. And what I'm saying, public outside of that class. If you make those public, any class outside of that can access the variables and change that to whatever they want to directly, right? By private, that's when we're encapsulating that. We're doing data hiding. And the only way to change the values of that is using those property methods, right? And, we've seen the get and set, but you don't have to have both get and set. You can have just get, where you prevent them from even being able to set a value on that. And in certain circumstances, you're going to want to do that. Let me see. I don't know if this really works as well as I'd like it to. Okay. So here's an example of a property, a read-write property, where you can do for code, capital C for code, right? Whenever you see capital C, that's what you should do for all your properties. Always make sure you got a capital C, or well, first letter being capital, right? Now you can hear it's going to return the code, and that code's going to be defined at the top of your file, right? We had that code defined at the top of your file, right? So it's doing a get or a set, and a get's just going to return the code. Here it's basically doing a set, and what's going to do is say set the code, right? That's at the top of your class file, and set that to whatever value that you set it to, right? This is just a keyword, right? You don't actually put the name, you don't replace this with a certain value. You actually use this keyword. And so when you set code equals, 1, 2, 3, 4, the value, it's going to actually put that right here into the value. And like I said, though, there's possibilities. You don't even want somebody to be able to set these. So you can just get rid of the set altogether. And then also within a property, like we were just saying here a minute ago, is you can have other code within this. You may have other code saying, hey, if this is greater than this, or you can have some data validation going on, saying making sure that this is the right kind of data, and so that's other options as well. And so basically, and then if you already know that you don't want it, you don't want it to be set again, you can do the read-only property though, right? But actually, even if you didn't put read-only on there, you're preventing somebody from setting that again. Sorry, that's probably confusing to you, but yeah, it's a good idea if you're not gonna, once something's set, you're not gonna want to be that being set again. You would define it as read-only up top, and then you would never provide a set method as well, right? So this is called the get accessor, and this is called the set one, and it's also called the getter, getters and setters, right? So most of the time, code's changed, and the language has changed and evolved over time. But you used to always do get code, set code, and they'd be separate methods like that. And I know some of the labs and hands-on tests for Chapter 12 is going to tell you to do it that way. And so that's kind of more the more traditional way. You have a get code, set code, and you actually write it just like that. This here is a newer kind of way to do this, by just doing a code, defining a code property, and doing a get and set all in one thing, right? But you could also just have a separate method for get code and a separate method for set code. So you use a property to get and set data values associated with an object. Typically, each property has a corresponding private instance variable that stores the property's value. It's common to use the same name for the property and the related instance variable, but to begin the property name with an uppercase letter and an instance variable name with a lowercase letter. You can code a get accessor or getter to retrieve the value of the properties. Often, the get accessor simply returns the value of the instance variable and stores the property's value. Often, the get accessor returns the value of the instance and stores it. Okay, I can see what they mean there. You can code a setter to set the value of the property. Often the set accessor simply assigns a value passed to it via a value keyword to the instance variable that stores the property's value. A property has both a get and set is called read-write property. A property that has just a get accessor is called a read-only property. And a property that has just a set is called a write-only property. So a lot of times when you have objects like this, you're creating these kind of objects usually for they're data related, right? They're either getting values from a database, or creating objects to set that data on a database. And like we said earlier, you can also persist data, right? Persist data to the file system, which is can used sometimes, but for the most part, usually you're talking about using a database. So when you're doing a get, you're usually you got back in your business layers where you pretty much called your database layer and said, hey, go get me all this data, and it could have returned 200 objects of data, right? And then when you're doing a get on that data, you're reading the data, right? You're getting the data. Then if you're actually going the other way, maybe you've got a form where you got 10 different fields on your form, and you fill in all that data on that form. When you submit that, you're doing a set, and you're setting that data. You're using that data based on your business tier, your business layer, and then you're setting that and then passing that to the database tier or layer that actually saves that to the database. So that in that case, you're doing a write, right? So here, I did want to bring up this because this is important. So, most of the times when we have created, chapter 6 created methods, but there's this concept of overloading. And when you overload a method, you code 2 or more methods with the same name. So you have the same name, okay? But with unique combinations of parameters. So maybe you have a method called display fields, but display fields, one of the methods might display fields and have an integer, and then you have another method also called display fields that has a string. So basically you can have 2 methods with the same names but different parameters, okay? So when you overload a method, you code 2 or more methods with the same name, but with unique combinations of parameters. In other words, you code methods with unique signatures, okay? For a method signature to be unique, the method must have different number of parameters than the other methods with the same name, or at least one of the parameters must have a different data type. Note that the names of the parameters aren't part of the signature, so using different names isn't enough to make the signatures unique. Also, the return type isn't part of the signature. As a result, you can't create 2 methods with the same name and parameters but different return types. Okay? That's important there as well. So if you have methods with the same name and the same parameters, both let's say had one int, one string, and both methods had int and string the same name, but you had a different return type. One returned a string, the other returned an int. That you can't do that. Okay. The purpose overloading is to provide more than one way to invoke a given method. Okay. Let's take a look at this. So a method that accepts parameters. So here's a get display text. Here's one with one parameter that accepts parameters. Here's one that doesn't have any parameters. And this is called an overloaded version of the get display text. Okay. Two statements that call the get display method. So obviously, if if you call it this way, it's going to call this method. If you don't send any parameters at all, it's going to call this method. To provide other classes with access to a method, you declare it using public access modifier. So, that's one thing you always have to make sure that because we talked about private, and it's always, I would say by default, no reason to make a instance variable public. You probably should all, best practices, make those private, unless there's some reason you need to make those public. But you do need to make the methods public if you want any class from outside of that class to be able to access, your variables or any other method, right? You could have other methods in that as well. Let's just say let's say we have a car object, and you have a car object, and you have different methods. One of them start car, one stop car. Well, if you want the calling class, another class to be able to start the car and stop the car, right? Then you need to give them access to that, and you do that by making those public, right? If you make those private, then you're only going to be able to access those methods within that class itself. Let's go ahead. We've been going for almost an hour here. Let's go ahead and take a 15-minute break and come back, and we'll continue on from there. So as we already seen, we have a constructor with no parameters. Always remember for a constructor, it always has to be the same name as the class. Uppercase, same spelling, same name as the class. And that was the no argument constructor. And this one has 3 parameters. And this is the one we kind of already looked at. Now here's another one, and this is a common business use case. Here's a constructor with 1 parameter where you would be calling you would create a product, and you would actually you just send in a code, right? If you have the code to the product. So usually let's just look at it from a standpoint. You've got an application that you've got all these codes, and you can actually put in the code. You hit get, and it's going to go ahead and it's going to instantiate the product object, right? It's going to basically what it's going to do is you're going to pass in the code, and this code's going to go to like a project. Here's a product database, get product. You're passing the code. This is going to return an object, okay? A product object. Obviously, this has to be all set up that the database is actually returning a product, the correct object with all the data. But in this case, a product database, get product, would return all the data for a specific code, and then from there, this product that got created already has the data. This where you see this is the data from the database, right? The code, the description, the price. This is all from the database. Okay. So you kind of can, create an object from different perspectives, right? You can create an object from the front end, right? From your presentation layer to your business layer, because you're going to save some data, right? So there's that use case where you're saving data that you're going to create for a new product. You're going to create a new project object, set all the data on that project, on that product. Then you're going to send that to the database layer so it can persist on a database. Then there's the other way, the other trip where you're basically from a presentation layer, you want to get some data based on the code you have, right? So you have a code, And then basically you're going to go ahead and do a request from the database to return you a product object that has, the description and the price. Okay. This is showing you basically how to call these constructors. With the no argument constructor, you just call it like that, right? And then here's the new product. This is where you've got 3 parameters. And then the third one is you're calling that overloaded parameter that just has the code only. Okay. The name of the constructor must be the same name as the class. A constructor must always be declared with the public access modifier, and it can't specify return type. To code a constructor that has no parameters, code a data type and a name for each parameter with the parentheses that follow the class name. The name of the class combined with its parameter list form the signature of the constructor. So always remember, it's the name and your parameter list is the signature of the constructor. Has nothing to do with the return type, just the name and parameter list. If a constructor doesn't assign a value to an instance variable and that variable wasn't initialized when it was declared, a variable will be assigned a default value. So yeah, I should have talked about that a little bit. So, different things have different default values. And I do want to mention something that we're going to talk about more later on as well. But like an integer is going to, if you declared an integer but you didn't initialize the value, right? You didn't set a value to it, then it's going to return a 0, right? And then a decimal is going to return, a 0.0, et cetera, et cetera. There's default values. There's default values for all the primitive types, right? The int and the double and the decimal, right? Byte, char, there's all these different primitives. There are default values for those. One thing you do have to be careful about, especially when we start working with objects and we have strings and stuff like that. So a string by default has null, right? And so you have to be very careful with strings because if there's some in your code someplace, especially when, we were doing for comparison purposes, we were doing like 2 lower. You can do 2 upper or 2 lower, but like doing 2 lower to do it the lowercase. Well, if that string hasn't been initialized with a value, it's null. And if you do a method call, like some of those built-in methods like 2 lower on a null, on a string that's a null, you'll get a null exception. So something to keep in mind, and we'll talk about it more in the future here, but just wanted to kind of mention that. Same thing with an object. An object by default is going to be null. If you can declare an object called product and not even do new on it at all. That's going to be, by default, it's going to be null. So static members are members that can be accessed without creating instance of a class. Okay, yeah, let me, I think I'm going to pull up something else here because I want to show you something. So there's this W3 schools. Some of this stuff might be a little bit outdated in that, but it's still pretty good. And I suggest you go ahead and I'll go ahead and send you some links, but you can do some different things in here. Create objects. It goes through different things on C#. Right. One thing here. So I wanted to kind of do here. So here's this car object. Okay. And we've got a car. The string type is color equals red. So we initialize this. So this here is a instance variable, right? This is an instance variable. And so it assigned it red, right? So what if instead of doing that, we made this static? Okay. So if you make this static, what that means is this belongs to this class, and you can access this without needing to create a new, without having to create a new object. Okay. And just to back up a little bit from that, so for programs, for basically any even class you create, you can always have a main method. You have to write it exactly like that, right? But a main method's kind of it's a special kind of method that actually, and as we've did those console apps, each one had to have a main method because that's kind of the entry point into your program. That's the entry point. It's a little different with WinForms because it's all wired and it's a little different, right? But for a console app, and even you can always add a main method to one of your objects to test it. Basically, there may be different reasons you're wanting to do that. Okay, but you can add a main method to any of your custom objects you create to actually test it. And so in this case here, and basically the main method's always static because to be able to access this, you're not going to access this just by calling this car, right? You have to have a main method. You have to have a main method. It has to be static because you don't have an instance of a class. And in the side of the main method, this is where you create your instance to your class, right? But you'd never be able to get in here unless it's static, right? Maybe that's a little confusing. When time, as time goes on, it'll make a little more sense. But here I changed this. This was string color. Originally it was like this, right? Here, let's just do it. I think it's already showing you the answer over here on the red, but you run it, it's going to be red. Okay? But if we make this static, let's see what happens. Okay? And now we'll run this. We're going to get an error. And it's going to basically say that the main application.car.color, right? This is stating the namespace dot, class name dot, color cannot be accessed within an instance reference. Okay? Because you're saying, because the static variable doesn't belong to the object, it belongs to the class. So actually, the way you can refer to any static variable that's defined in the class is by just doing this. Car.color. So you're saying the class name dot variable name, okay? And now if we run this, it'll come back as red, okay? What else did I want to show you? So let's do this as well. Let's put this back to, let's put that back to that. Now here, let's just run this for the heck of it and see what happens. Since we're here, we're going to get an error because it's going to tell you an object reference is required to access a non-static member, okay? So in this case, that's where you're really wanting to do, you need to do, all right. Let's make sure it works before we go on. Okay. Now here, just want to make sure, we've already kind of discussed this, that basically, and you can change, that's what's kind of nice here if you just want to play around with something. You can obviously do this within the IDE yourself and that. But, maybe you want to play around. It's just an easy way to try some things. So here, let's just do this. So we got object 1. And let's do that equals blue. Okay. Let's do that. And then object 2 is new car. So let's do this. And we'll do this one as 1. And this one is, let's not do that right like that. Let's just wait for that one. So hit Control S, bad habit. Control S, I always save things. I don't need to do that here. So here, so we're taking the, I did that wrong. I need to do this, all right? So we're going to change the color to blue. So we got object 1 and we got an object 2, both new car instances, right? Instances of new car objects. And so my object 1 dot color, we're going to change that to blue and we're going to print that out. So you see blue here. But, you know, I just want to make a point here. You know, we kind of already talked about this. They're separate instances. So even though, so the new car has a color of blue, the object 2 is going to be red, right? Because it has its own copy. Each object has its own copy of whatever variable. You could have 20 variables in here. It's going to have a copy of each one of those variables. These are all called instance variables. So it's going to have its own copy. So in this case, object 1 has a color of blue and object 2 has the default color of red. Okay. But this is a nice little, you know, nice little tool you can use to play around. And then also, you know, it has some, if you just even want to go back here and it, you know, it has a lot of information as well. You know, what is OOP, object-oriented programming, because that's what we're covering here, but it's going into more stuff than we're going to cover right away. We kind of talked about encapsulation a little bit, but it's going into other areas as well, which we'll eventually get to. So, just wanted to show you that. Okay, so static members are members that can be accessed without creating instance of a class. And so we've seen that, how we did car.color, right? Car.color can get it. You can get access to that if it's a static, if you defined it as static. The idea of a static member shouldn't be new to you because you've seen them in several chapters in this book. Okay. To create a static member, you simply include a static keyword. Okay. Okay, well, yeah, this is basically saying what I actually did there was kind of a little more old school, more traditional, is basically with later versions. And later you can refer to the static member of a class without naming the class. So you could have just, we could have just said color, right? So this is just showing the same thing here. Okay. A static member is a field, property, or method that can be accessed without creating instance of the class. To define a static member, you use the static keyword. So we were doing the field, and we also see the main method. The main method's static because that main method is kind of an entry point into your class. And if it wasn't static, you wouldn't be able to, you can't get in there unless you create an instance of that object, right? So to get into a class as being an entry point, it has to be static, okay? So static properties and methods can refer only to other static members or to variables declared within the property or method. Yeah, so we have those, you know, like we have the main method, which was static. You can access things if you instantiate it, right? But you can't access those instance variables by itself, right? Let's just go back to that real quick. I think I have that right here. So So here, yeah, just like we just want to, let's get rid of that, and let's just do the color. Like it said, you don't have to have the class name ahead of it. This is going to complain. Well, yeah, because I didn't make it static. An object reference is required to access that, as we know. So it can access if it's static, but if it's not static, it's gonna balk at that, right? It's can't access non-static member. Okay. A constant that's declared with a public keyword is implicitly static. So whenever you actually define a constant, okay, even though you don't say it's static, implicitly, right? Do you remember like the concept of implicit and explicit? Explicit is when you put static on there, you can actually go ahead and put static on a constant. That's, but you don't need to because it's implicit, by nature. Because a constant is something that is meant to be able to just access without having to create an instance variable, right? Create an instance of a class, I should say. I'm sorry. So if you create an object from a class, you can't refer to a static member through the variable for that object. Right? So we kind of already seen that. You can't do, if it's static, you can't do my new object dot color. You can't do that if it's a static, right? Okay. We're going to go ahead and look at this. We're just going to click around more than anything, and I'm just going to show you a few things. We're going to go ahead and look at this program here. Hey, first I just wanted to show you real quick here before we go any further. So here's our program, right? So here you can actually go to create a new class. To create a new class, you go up to Project, Add Class. It's very simple to do this, but you just need to make sure you've got the right things highlighted here, right? So if you do, not solution, but actually this right here, right? Not the solution, you don't highlight right here. And then do a project, add class, right? And then my new class, and just click add. Didn't I find the element hierarchy? I'm not quite sure on that. It might have been because I was doing some other things. But it created the class, my new class, okay? It's at the same level as the product here, so I don't see why it would be a problem. It's in the same, I don't know. I don't know what happened there. I probably should have read that a little more carefully. Still in the same namespace, but so, I created this my new class, and then here it is, and then, you just go from there, right? So that's how easy it is to create a class. But we'll get back to this. So we got this, let's just go ahead and run this thing. Maybe it won't work. Maybe that's why it's complaining. So I was already playing with this. So actually you can, and this is like, we're talking about persistence, right? So you can persist data to a database. You could persist data to, a file system. There's other ways as well, but, for our purposes, best probably just think in terms of, either persistent data to a database or you're persistent data to a file system. And so here, actually, this is persistent. This data is actually persistent. And I'll show you that here in a minute. But basically here, and actually we're using multiple forms, and we'll learn this in the future as well, that you add a product and it's going to pop up. So we've got the product maintenance form, right? And also we have this new product form. And we could just add a code here, a description, and a price. Well, let's call this something. Hit save, and it's just going to add this to this list. Okay. And what this actually is doing, and we'll look at the code here in a minute. Let me find this. It actually, in the code, it's putting under C# files. It's doing this all in this code. You've got customers and products. So here's products. And actually, this is a file, products.txt, that's putting all this. We just added this last one. So this is persisting this data to the file system. And it's using, when you're, this is basically called a pipe, right? Right above on your keyboard, right above the backslash, is the pipe. So it's using a pipe delimiter to delimitate the different parts of the product, right? First one's code, second one's a description, and the third one is the price. All right. So something else we can do in here. Here's especially when you start getting more involved, it's a good idea to be able to use these different tools. Right click, and then you can go to find all references. And so in here, we'll find all references to this product, right? And you can see it's being called from the database over here, product DB. It's being called from forms, right? So let's look at the form for this, get new product. And so this is a form. And then you can see you've got, this is a private instance variable that has but it's a type product. We were looking at instance variables being primitive data types, but this is actually a private instance variable of type product. Okay, and we've got to get new product, right? Checking see if some data is valid, etc. Okay, and this is new product, and that's all that new. When we click that button for new product, that's what it's doing, right? And there you go. Product equals, so button.save, when we put the data in, hit save, it's actually creating a new product, right? It's setting product, this product equal to a new product, passing in the code and the description, and it's converting to decimal the price. Okay, and don't worry, you don't follow all this. I'm just kind of wanting to give you a little view of it. So here in our product DB. This is our, database, even though this isn't really a database. It's just basically, it could be called something different than database, but, depends on your view of what a database is. But, basically, we're persisting data to the file system. We're not really persisting it to an external database, right? There's different kinds of databases. I haven't really discussed that much, but, there's different companies that make database, Microsoft have their database, Oracle. There's all kinds of different companies that have different databases. There's even free ones like MySQL and so forth, right? But here we're just persisting data to the file system. Basically, this is stating where it's going, and it's going to this files directory, all right? And then here's the name of the file it's creating. And it'll create this if it doesn't exist. If it does exist, it's not going to do anything, right? It just skips it. So, and as you can see, read the data from the file and store it in the list. So this is getting the data that already exists, right? So in this case, you're getting the data. Let's see where that's being called first. Product, text in. And don't have to worry about all this, okay? But this is basically file access, right? You're accessing that file, right? Based on that path, the path you defined up here, right, is the directory plus that. And then you're reading each line of code, and then you're using the split to split it, all right? At the pipe, and then you're populating your code based on the first one. You're saying the first column. So your first column is code, the second column is description, and the third column is price. And then you're adding this product to a products list, right? So, a lot of these labs and the hands-on tests we'll be doing next week on Chapter 12. You're going to probably be using a lot of lists, but, we were doing a lot of lists, either of strings or whatever. But in this case, we're going to be using list of objects, right? And here you're just adding here it's just adding however many's in that list, right? Or however many is in that file. It's creating a list of all the products. And then here, it's basically saving the products by, it's pushing the whole list. You could do it this way, I guess. That's the way they decided to do it. But if you're just doing one product at a time, you could always just add one product, right? You make changes, you hit save, and just save that one product. Here it's passing the whole list. It's writing it out each time. So let's, just for fun here, let's, and this is something that's going to come in very handy going forward here. So making sure you use breakpoints, right? So let's go ahead. This is doing a get, right? So let's just click on this. And it's already stopping at this point, right? So I put a breakpoint. It's stopping at this because it's already calling this method to get the products here, right? So something that's very useful here, debug, and then doing a quick watch. You can watch different variables, in this case, products. Okay, in this case, this is the first time in. And so products is 0. The count is 0, right? And we'll step over that. So here we go. We're just kind of stepping through this. So each time we're adding if you hit continue, it's just going to continue to the next breakpoint, right? If not, if you click here and just keep going, step over, it's just going to go to the next line, next line. But if you have a breakpoint, especially if you've got a loop, it's going to continue and keep coming to here until it's done. So in this case, so you've got all this. You keep on adding to that. So here, did we didn't really put, yeah, this is the list. So you can you can expand this and you can see each one. You know, this is very handy going forward, right? So you can see different values. Here's your code, description, price, code, description, price. And it's going to keep going. It's going to end up eventually, boom. So we had what? 1, 2, 3, 4, 5, 6, 7 of them, right? Get rid of that. I didn't really look. I guess it's what it's doing. Oh, it's rewriting the whole thing. Because what it'll do is the way to delete, it's actually rewriting it every time. So then if it's not there, that's how it's rewriting it. So here, by deleting this, let's save products. I don't want to put that there. Let's put that here. So here I delete this first one, 1, 2, 3, 4, hit delete product. Pop up, are you sure you want to delete it? Yes, I do. And so basically what this is doing here, just make sure, yeah, count 6. So basically it's going to, it don't have that. It's resaving the whole, whatever's in that list that you see in your UI, it's only going to save what's there. You know, there's other ways to delete. Sometimes you can just delete one row. You know, this probably makes a lot more sense, especially with a file. With a database, it's not very efficient. You know, you could have thousands of products, and so you wouldn't really want to do it that way. But in this case, you know, this is just a little sample thing there. So you're basically, you know, rewriting the whole file each time, right? So whatever values you have. So, you know, I just want to kind of show you a little bit of this debugger. So you can always debug and look into see what you're doing. So you're wondering what's going on, right? And you can pretty much you can do a quick watch on any variable that you want. Okay. Let's see. So just to review here a little bit. So for product, right? So we know that these are private instance variables, right? The only way from outside this class, the only way to access these private, these are also called fields, right? But these are private instance variables or fields, private instance variable fields. And the only way to access them outside of this class is by using the properties, okay? And in this case, we've got, like for the first one, code. You want to make sure your property that you go ahead and have it uppercase, okay? That's the convention. And then make sure it's public, right? So outside the class, for something outside of this class to access this, to do a get or set, it's going to have to be public, right? And then obviously, if you didn't have a setter here, it wouldn't allow you to set it, right? And like it kind of said in the book, well, you know, one way to actually do that is also, you know, create like, it showed a case where you had a code and then you actually populate it based on the code. You were getting the description and the price. So these could actually be read only, right? Depends on your purposes, what you're trying to do. right? So, but these are the private instance variables, and these are what we called, this is the following the object-oriented principle of encapsulation. This is encapsulated so that nothing can access this outside this class, right? It's called data hiding, right? This is the no arguments constructor, no parameter constructor. And this is a overloaded constructor, a secondary instructor. This one has code, description, and price, so that you can actually just pass the values straight in, calling this way. Otherwise, for this, you would have to do product.code or product.get code or product.set code or product.get description or set description. Same with price, right? That's how you would do it if you call this type of constructor. And I guess that's about it. Always remember that your constructors have to have the same name as the class name, and they have to be public. They have to be public. All right. Let's see here. So kind of walk through that. We did create that C# class real quick, how easy that was. Just to review that real quick. So basically, so as long as you're there, you go up here and do a project, just add class, and you can add a class. Okay. Okay, the next thing I want to go over is UML. And the reason for that, I'm going to actually just show you the lab real quick. So basically, this lab here, this is part one of this lab. And in this lab, it's the first one's flashcards. And basically, this has this class diagram. And this class diagram is considered a UML diagram, okay? And so you're going to need to understand how to decipher this to be able to use right? Because you're going to be using this to determine what you're going to be creating, okay? So we're going to go over UML a little bit here. So we can so you can understand how to do this. First, just want to kind of go over some of the basics. So here's a list of different UML diagram types. So what we were just looking at was a class diagram. So there's different kinds. And basically, UML stands for Unified Modeling Language. And it's been around for years. And the whole purpose of it is to be able to define systems, systems and relationships between different parts of a system. And boils all the way down to even, like in this case, it's showing a deployment diagram. There's all kinds of sequence diagram would be like, you could create a sequence diagram of logging into a system because, some systems are a little more complex than others. And there's sometimes multiple stages with logging in. You click, how do you get to the login? And then once you get to the login, you enter that data to log in. And then, there's other things that are going to be on that page, maybe reset password, etc. It's you could do a whole sequence of all the different things that are part of logging in. It's, a lot more involved than just putting in a username and password, right? Because you might have other functions that need to be also done on that page as well. And then if your password's expired, you got to return the right things. And all of that can be done with like a sequence diagram, right? But there are all kinds of different diagrams, okay? And we're going to be looking at class diagrams. But the whole purpose of Unified Modeling Language is kind of creating a general type. This isn't just for C sharp, right? This is for any programming language, any kind of any system, any software project, right? So it's kind of a standard modeling language used in software engineering. It provides a visual way to represent the structure, behavior, and interactions of a system, right? So you can visualize the system, and also it's good for, communicating with others. Some people have different levels of technical understanding, right? And so, it's nice to be able to have different diagrams that explain what's going on, because not everybody's technical. Not everybody's going to understand those class diagrams, right? So there's different diagrams for different purposes as well, right? There's a whole, I'll give you some links on this. It can be, it's very in depth. There's a lot to the UML, this to the unified modeling language. There's a lot to it. But we don't really need to worry about all of it. It's good idea to understand the basics of it. Okay. But for our purposes, really what we're going to refer to more as this class diagram. Okay. And in this class diagram, you can see that here's a class diagram for order processing system. You've got a customer, you have an order, you have a product, you have a stock, right? So it's showing you, and basically what this means here, let me show you something here. It's basically saying you've got the name of, so if you're being presented this as a developer, a programmer, and you may have a systems analyst, or your technical lead gives you a class diagram, says, I need you to go ahead and add this to our existing system, or it could be a brand new system you're creating, and you're in charge of the you're in charge of the order processing system of this, and so you may be given something like this. So the customer, this would be the name of your class, customer, right? And then obviously, since we know that your constructor is the same name of the class, you're also going to have a customer constructor. It doesn't show that here, but I'm not sure why it wouldn't be showing that. But it is showing you have some different instance variables: customer ID, a customer name, an address, and a phone, right? And so, and if you see this little minus sign here, this little dash, so a dash before here means that this is private, okay? So this is going to be a private instance variable, right? You could have a private or public, but it's telling you this is a private instance variable, and it's telling you, okay, and besides that, this is for the variables. This down here is for the methods, and this is saying, okay, I need to add customer, I need to edit customer, and I need to delete customer, okay? And then in that, it has a plus sign in front of it. So what's that meaning? It's going to be public, right? So these are going to be public methods that you can add a customer, edit a customer, delete a customer without any parameters, okay? Without any parameters. Sometimes you got to watch how they, sometimes they might label things a little differently. So let's go here, look at the stock one. It says modify stock. This is an integer, right? A product ID. This is showing you the exact method, right? But sometimes they do this a little differently. They might start out with the name of the variable, right? The name of it, and then have a colon and the type after that. And so I'm going to show you in the ones we're using for our labs, it's done a little bit differently. Okay. But that is a class diagram. And, let's just look at a few of these just so you can have some exposure to this. Here's a use case diagram. And so basically, you basically have a user that can buy an item, a user can recharge an item, can check an item, can set machine, whatever this all was about. but this is a what's called a use case diagram. It's a diagram type of a behavior, right? It's just giving an overall view of the actors involved in a system, different functions needed by those actors, and how these different functions interact. Okay. Back up to the top here. But it'd be worthwhile to spend a little time understanding some of the basics of this. It's not, you're not going to be tested on this, but in the real world, it's, UML's used, substantially within the software industry. So, but the use case one, activity, sequence diagrams vary. So this is actually showing two different classes here. And it's showing class A and class B. And it's just showing that the class A can create a new instance of class B. And then class B returns to class A. This is showing interaction between two different classes, right? Showing that class A sends a message to class B, but class B sends a message back. It shows it cannot delete it, and there's no delete. Or well, that it does delete, right? So there's lots of different kinds. So let's go ahead. It's about 10:05. Let's go ahead and how about we just take 10 minutes and come back at 10:15, and then I'm going to go through the labs and go through the UML, the class diagrams, at least for that first lab, and we'll go from there. So just go ahead and come back at 10:15. Thanks. Let's go through these labs. So the first one here is flashcards. It says the program can store definitions up to 20 terms. The program comes with 5 definitions included. Users can enter a term to get a definition for that term. Case-insensitive search. If the user enters a term that doesn't have a definition for, then it will display, I don't know that term yet. What does it mean? And prompt to enter that definition. So here, basically you're going to be probably best. I mean, I don't want to say there's only one way to do something because that's never true. But, so you got probably flashcard objects here, right? And these flashcard objects, you're going to create 5 of them, right? And they're going to need to be persist at least. You don't persist them in a file or a database, obviously, but you need to hold on to those values. So you'll have to define that at the class level. So you'll have a list of flashcard objects, and you'll create 5. Initially, you'll create 5 of them. And then you'll also be able to add up to 20. So you'll have somewhere in your code, you'll probably need to check to see how many you have. And then if you once you have up to 20, somebody adds the 21st one, you just pretty much respond saying that, that reached the maximum of 20, right? Something like that. I don't know. But yeah, it's going to be a list of objects. And then so down here, this flashcard, this class diagram. So this basically saying you've got a private instance variable. And they're using, there's naming conventions are always interesting. And I've kind of, shied away from that a little bit. Just, Microsoft will actually, Microsoft says something, but then I look at code that they actually have on their own website and they go against their own naming conventions and stuff. But here it's basically saying you've got private instance variables, and to start that private instance variable with an underscore, okay? So underscore term and underscore definition, okay? And then here it's saying you got three. Basically, the first one's a constructor, right? If it's the same name as the class, then you know this is a constructor. So you got a constructor that takes and as you can see here, it shows term, colon, string. Well, you pretty much got to, flip that. You have a string of term and a string that's the definition, right? And then you're going to have a get term that's just going to return the term, and a get definition that's going to return the definition. So as far as setting, you're not really setting anything here at all. Well, when you set it, you're setting it when you call the constructor to create it. The flashcard constructor, you do a new flashcard sending it, right? The get term and the get definition, it's going to have to query it's going to have to loop through your flashcard objects to find the, term. See if the term exists, then return the definition, right? But just go into the class thing a little more, even though this one is the most basic one. Maybe for the more complicated ones, I might create something. But here's a flashcard UML, and basically this is explaining exactly what we just discussed there. You've got class members. Here's your underscore term and underscore definition, private instance variables, right? Each of type string. Public, a plus is public. We don't have to worry about protected right now, but at some point we will be using protected as well. Protected is a pound sign or a hash, and then a private is a dash, right? Symbol for private. And then here's the constructors, your flash card. Just telling you your parameters. And then here's your method, get term. That's a string, and get definition. And this is basically, saying it returns a string, all right? And then actually, this one, we'll give you the code. So this is basically showing you the code. I'll probably do, I don't know how many of the labs I'll create a little UML for at least one, maybe at least one more, or I'm gonna have to look at it to see. But I want you to be able to understand it. I don't want you to be lost in that. So I'll provide that as well for you for the lab. And so here, this next one is store inventory. Program has a pre-populated list of items. Each item must have a different UPC code. The program can track up to 20 UPC codes. The user can search for items. The user can add new items. The user can update the price of items, and the user can delete items. So once again, we're just going to be using a list that you're going to define, and then you're going to be able to add up to 20, right? And then you can search on that list. You can add to that list. You can update a price on that list, or you can delete one of the items on that list. So, and then let's see, that didn't even come with any UML at all, did it? I don't think so, unless it got deleted by mistake. I'll have to check that out. Make a note of that. So here's a bank login, and this is the Wayland Bank. We've seen this one before, but what's going to be different here is instead of how you did it before, you're basically going to create an account object, right? So here's your private instance variables. Here's your constructor, your account constructor. Here's your methods for get account number, get PIN, get name, get balance. And then you can also make a deposit and make a withdrawal. And this being plus signs, so these are all public, right? And always remember that your constructor needs to be public, right? That shouldn't be bad at all as far as the UML is concerned there. But, this is pretty similar to what we did before. The program should have at least 5 accounts, which you kind of, I don't know how many you had in the beginning anyhow. But the whole thing is just to turn what you did already, turn it into using objects, account objects. And then we've got game break. And then here, pretty much the same thing as well, because you kind of did this before, I believe. And so he was giving you some more information. Basically, here, your game object. You're going to have your game constructor, your public methods, and your instance variables. Okay. So for the ones that, it has these methods, get name, get publisher, and get price. I know we looked at, there's different ways to use those properties, but for these first 4 labs, why don't you just, go ahead and follow like this, right? But actually when you get here, you can go ahead and use kind of the properties that we were kind of looking at on how to do the properties using the get and set for description, hours to complete, hours fee, and total fee, and do it this way, okay? And so, yep, and notice here you've got a public, so here you've got a constant, right? Constant called trip fee, which is a double, and if being a plus sign, so that's going to be public, right? Public. The minuses are going to be private, and here's your public constructor. Yeah, this is how typically you see. You don't always have to have this, but it's kind of helpful to have the little constructor stated. But obviously you always know if you've got something in here that's going to be the same name as your class, it's always going to be a constructor. So then here we've got a tile estimate. So you got your instance variables, your constructor, and you've got this other method called display, right? And then you've got the, here's your properties, right? You can do the properties just like we've seen earlier, how to do the sets and gets on properties, right? So that's it. I don't think, I don't think that you really need any more specific information on reading the UMLs on this. The part 2 ones are a little more complicated.